Alright, in this video we're going to define what we call addition or adding vectors. So if you consider two vectors AB and BC, where the tail of BC is the head of AB. So you have the vector AB here going from A to B. So that's its tail to the head, the arrowhead right there. And then B to C, so there's the vector BC. Then the sum of these two vectors, so the sum of AB and BC is, well, we'll write it with a plus symbol, so AB plus BC will be a vector, and that will be the vector starting at A, finishing at C. So that would be the vector AC. Okay, so that's how you define vector addition. Okay, so if you take the two vectors you're adding and place one at the head, one tail at the head of the other one, then the vector, the sum is the vector starting at this tail, finishing at this head. Okay, so that's kind of just a definition right there. Okay, so for another definition, we define what we call the zero vector. So the zero vector is a vector, but it's a vector with no magnitude, or its magnitude is zero, or direction, so it has no direction. The way we write the zero vector is with the symbol 0 with the vector symbol over top. The reason that you need a zero vector, so consider this example. What happens when you add a vector AB plus its opposite vector, negative AB, or BA? Well, it's actually, maybe I'll write that. That would be equal to AB plus BA. So if we think about what's happening there, I've got a vector, starting at A, going to B. But now if I place, if I go tip to tail and I place vector B, the vector starting there, then I go back to here, well, what happens is I started here, went to here, then came back, and I'm back where I started, so I haven't gone anywhere. So the answer is going to be 0. And sometimes people say, well, why can't you just use the number 0? Why do I need this vector 0? Like, what does that mean? The reason you need the vector 0 is when you add two vectors, you want the result to be a vector. So you can't get a scalar when you add two vectors. So if we're going to have this possibility where the sum of two vectors is 0, well, then it has to be a 0 vector. It can't be a 0 scalar. Okay, so that will be useful, this idea of a 0 vector. Okay, so now we're just going to do a quick example about adding vectors. So we're going to consider the rectangle ABCD. So draw a rectangle. That's should be a rectangle. Label, remember you always label counterclockwise. And now what I want to do is I'm just going to calculate some sums here. So what is AB plus, well, BC? So AB would be this vector here, starting at A, going to B, and BC would be this vector here, going from B to C. So AB plus BC is a vector starting at A and finishing at C. So that would be the vector AC, similar to our definition. Let's say we want to go AD plus, let's say we want AD plus AB. So this one's a little bit trickier because AD is here and AB is here. So the problem with this one is that they're not head to tail, right? The tail of the second vector is not at the head of the first vector. But what I can do is I can replace the vectors with equivalent vectors. So AD is here, but notice that DC is equivalent or equal to AB. So what I could do is write this as equal to AD plus DC. So notice what I did is I replaced this vector with this vector, and that's okay because AB and DC are equal. Okay, and now I have AD plus DC, so it kind of makes this triangle here. So now I've got the vector AC. Okay, so that's that sum. What if you went AB plus BD plus, and I haven't defined this, but we're going to add 3 vectors, plus DA. So adding 3 vectors is just like adding 3 numbers. If you think about how do you add 3 numbers, what you do is you add the first 2, get a result, and then add it to the third one. Now, when you do this with numbers, you often just kind of do all 3 in your head, but what you're doing is you always add 2 of the numbers and then add it to the third. So we have to add AB, which is here, plus BD, so that's this vector here. So AB plus BD would be the vector AD. So you could replace this with AD plus DA. Well, notice what you have here. AD plus DA, that's a vector plus its opposite vector, which we know from the definition above. That's the 0 vector. So when you add all 3 of these vectors, you get the 0 vector. Something a lot of times people will recognize is you don't really need the pictures to do this. If you kind of just looked at the letters, what's happening is A, B means I start at A and go to B. But now I add BD, so meaning I started at A, went to B, then added from B to D. So that went from A to D, right? Kind of went all the way from A to D, which gave me the vector AD. And then now I'm at D, so starting at D, I go to A. So if you put it all together, we started at A and ended at A, which means we get the 0 vector. You just have to make sure kind of that these 2 letters match up and these 2 letters match up. Otherwise, you're not tip to tail, which you need to be in order to do vector addition.